Now let's look at this problem. Let's use like 15 seconds to read it. All right. Now we know that her time, her watch time is a little behind the real time, the actual time. I think we can write something like now 12 p.m. 12 p.m. This is the actual time. This is her watch, right? And after 1 hour, after 1 hour extra time, so we read 1 p.m. on the real watch, right? The perfect watch, and we read like something like this on her watch. Okay, so what do we have here? What do we have here? Actually, from this, we can know that the ratio of the speed of the actual watch to the speed of her watch, actually. We can think of the watch as like this, okay? The quartz watch, right? It has a face. Even if it is a digital watch, you really should think of it as this way too. So one circle, right? One circle of this perfect watch, the actual time will be one circle. One circle is 1 hour of distance. Actually, this is a distance. But her watch goes like this. Okay, this starts at the same time, but her watch, after 1 hour of real time, her watch stops here. So there is this gap between the actual time and her watch time, right? Actually, the time is the distance. Yes. So now we can write something like distance of actual time is going to be speed of actual time, speed of the perfect watch times t. Now this time t is actually 1 hour, right? And the d of her watch, the distance of her watch is like speed of her watch times t. Yes. So now we know that dA divided by dW is going to be, actually they share the same variable t, right? They're equal to each other. So d of A divided by d of W is going to be V of A divided by V of W. So what is this d of A? This d of A is going to be 1 hour of distance. It's going to be like one circle, right? And this d of W is going to be maybe, okay, so since it has minutes and seconds, maybe we can convert this 1 hour of distance into like 3,600 seconds of distance. So for this watch, her watch, Cassandra's watch, is going to be like this amount of time of distance, right? This is a time. So it is going to be a dA. Okay, I'm going to write it here. D of A is going to be 3,600 seconds of distance. Seconds of distance. And dW is going to be 57 divided by times 60 plus 36 seconds of distance. Yes. So this is your V of A and V of W. It's going to be uh, 3,600 divided by this is 3,456, and we cancel the common factors. We get like 25 divided by 24. So we know that the speed of actual watch and the speed of Cassandra's watch is this number, okay, 25 divided by 24. Now what will be the actual time when her watch first reads 10 p.m.? Actually, it means that her watch, like goes 10 circles, right? 10 circles, 10 circles. Circles of distance, and it is going to be v of w times t, right? Maybe t apostrophe, because this is another time, a different time. Now d of a apostrophe is what we want to solve for. It is going to travel like how many circles of distance, I don't know, but I know it is equal to v of actual time times t apostrophe. Now from this first one, we know that t apostrophe is equal to d w apostrophe divided by v of w. So we want to plug this t apostrophe into this one. So your dA apostrophe is going to be VA times dW apostrophe divided by V of W. It is going to be VA divided by VW times dW apostrophe of distance. Remember, this is the distance, and this is a ratio. And we know that this ratio is already like 25 divided by 24, so times 10 circles, right? You already know that this is 10 circles. It is going to be 250 divided by 24. It is going to be, let's see. Let's try this. 254 divided by 24. It is going to be 0.441, like 10.41 hour. It's going to be like times 60, because there is this like decimal, right? It is going to be a 10 hour 24.6 minutes. So if we check the answers, there is this 10:25 p.m. So I think that the answer is going to be 10:25 p.m. Also, you can convert the units from here. Actually, we know that it is like 10 circles of 10 circles of distance. 10 circles of distance, like 10 hours, right? This is what we know. And 10 hours is like 600 minutes, right? 600 minutes. So we can convert it from here. 600 minutes of distance. It is going to be 25 times 25 is going to be 625 minutes, and 625 minutes is going to be equal to 10 hours and 25 minutes. So the answer is also like 10:25 p.m. All right. So this is how we do it. We want to know that it asks us about the time, right? But it is actually a distance kind of problem.